Question number 1, to determine whether it lies inside or outside the circle. I guess step 1 could be to determine if it's on the circle. It's certainly not on the circle, because if it's on the circle, when you write the x coordinate where x is and the y coordinate where y is, you should get something that's true. And that's certainly not true. So it's not on the circle. Now, to find out if it's inside or outside, I'm going to determine that this circle has center 0, 0. That comes from comparing it to this template. That comparison says that the center which is a, b is 0, 0. So if you went out to the circle, it would be a journey of length root 30. Whereas if you go out to the point, it will be a journey of length root 29. How am I getting that? I'm just using the distance formula. So you subtract the x coordinates, subtract the y coordinates, and that's your distance. So yeah, because the distance to the circumference is longer than the distance to the point, the answer is therefore inside. Now, the mark scheme doesn't require that much detail, but that is a full, rigorous analysis of exactly where it is. Question number 2. The equation of a curve is this. Find the equation of the tangent to the point 3,9. This is the template for the equation of a line. You fill in all the algebra except for that and that. You want them to stay because it's the equation of a line. It should have algebra in it. So the y coordinate of the point it goes through there, it goes there. The x coordinate of the point it goes through goes there. And that's the gradient. How do you get the gradient? Well, there's lots of ways to get a gradient. The best way here is to form a multiple choice box. And now you substitute into one of the 4 places, either there, 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 or there. We have an x value. It's x equals 3. So put it over there or there. Which would you put it in? This row, because the whole point of that row is to find gradients. So if you put a 3 there, you get 19, I think. So that's the equation of a tangent. This part here is just to obey the rule that you should have y by itself, or 0 by itself, and 3 terms. So it's question number 2. Question number 3. Definitely going to need a diagram for this. PQ of this triangle is 8. RQ is 9, and RP is 7. Find the size of the largest angle. The largest angle will be opposite the largest side, so it's that one. So we're going to use the cosine rule on this. Call it capital A, little b, capital B, little c, capital C. How do I know to do that? It's because of your various formulas. You want the unknown, which I'm calling here x, to appear as close as possible to top left, which is capital A here. That's why I put it smack bang on the letter that I wanted to know. So we get cos x equals 8 squared plus 7 squared minus 9 squared all over 2 times 8 times 7. You get the answer for x by typing that, but going shift cos first. And out pops an answer of 73.4 to 1 decimal place. So that's the answer for Roman numeral part 1. Now that we know that, we can draw the triangle out again, just to avoid getting confused. We have an 8, we have a 7, we have a 9, we have a 73.4. So relabel the triangle. You don't have to stick to this labeling. You go C, C, A, B, B. Why am I labeling it like that? It's because the area of a triangle is half AB sine C. Where the A is, write an 8. Where the B is, write a 7. And just remember to use the answer button to type the 73.4, because 73.4 was just rounded. I don't know whether it was 73.4 or 73.39 or something. So I'll just write that to be sure. Anyway, you type that through and apparently you get an area of 26.8 to 1 decimal place. Question number 4, we have to solve this equation. And we're allowed to use values of x between 0 and 360. Immediately I notice a mismatch between those, so I bring them together by doubling everything there. And now from now on, let's say that the question is about u. That's just to reduce the complexity and keep my brain in gear. So what do I do here? We try and make it fit the template. The template is just sine of something equals something, cos of something equals something, tan of something equals something. Can't have trig on both sides. So we do a very clever red dude, which is always, you should always have close to the front of your mind. Still doesn't fit the template. You're not allowed to have a number multiplying by the tan. It literally just needs to be tan u equals something, which it now is. You pump that through a calculator. You get 21.8 apparently. You tug that against the x-axis 4 times to reveal your x-wing fighter. Decide which ones you want. Tan is positive, so we want that one and that one. Not that one, not that one. That's where sine's positive, that's where cos is positive, that's where tan's positive, that's where all 3 of sine, cos and tan are positive. So, if you're allowed to use angles between 0 and 720, how do you get to there? Well, 21.8 is certainly an option. Or, you could go there, which is 180 plus that 21.8. So that's 201.8. Or, you could go all the way around and then another extra little tuck there. So that's 381.8. Finally, u equals, go all the way around, go a little part again, that's 180 extra, then this part's, that's 561.8. So, therefore x equals half that, so 10.9. 1 decimal place. Use of a curly bracket to show multiple possibilities for what it could be equal to. 100.9 down 1 decimal place. 190.9. What's going on here is I'm just saying that 2x equals this. So what does x equal? That divided by 2. And then finally 280.9. 1 decimal place, and that's your answer for question 4. This thing of dividing both sides by cos to create a tan, very standard trick. If you're repeatedly not using it, put it on a summary poster or something like that. Question number 5. You have A, B and C. This is me drawing a diagram. That's A, negative 2, 1. That's B, 5, 2. Doesn't need to be super accurate for this. 4, 9. Find the coordinates in the midpoint of the line AC. So that one there, M. There's a formula for that. It's this plus this divided by 2 is before the comma. This plus this divided by 2 after the comma. So Roman numeral part 1 is that is 1, 5. Keep the diagram up to date with new emerging information. Question number 2. Show that BM is perpendicular to AC. Well, let's work out the gradient of AC, subtract the y coordinates, subtract the x coordinates in the same order.
To be fair, it's just I can calculate it. I got that right, I got that right.
Now do the same thing for MB. Subtract the y coordinates,
Which it is.
subtract the x coordinates in the same order. And you go therefore perpendicular because MAC times MBM is -1. That's just the formal way of saying that that's the negative reciprocal of that. So that's Roman numeral part. So that's part B. Sorry, that part there was A. That's part B. Part C. Use the result of part B to state the mathematical name of the triangle.
So when's the next day due? It's end of June, June 27th.
Now the mark scheme seems to want you to say that it's isosceles.
No, I get 344.
Just trying to think why it would necessarily be isosceles. It's only a right angle triangle.
Yeah, there's only one way, but we need to plan it quite quickly, don't we?
Just because.
That's alright, I'm doing
Oh, wait on. Sorry, that's a right angle. Oh, I know. The reason why it has to be isosceles is because that triangle is congruent to that one. It would be the same basic Pythagoras question. We know that that length is equal to that length. We know that that length is equal to that length because it's the same physical black line. So therefore, if you did Pythagoras on this, you get the same answer as if you did Pythagoras on that. So therefore, we should say that it's isosceles. Roman numeral part 2 is to prove this by another method. Well, I suppose we could do the distance formula directly. So subtract the coordinates. Do it again for this one. That's me subtracting the x ones. That's me subtracting the x ones. You don't just subtract the coordinates, you then square that difference. So I'm wondering whether they're equal. So that's 49 plus 1 is equal to 20. So therefore isosceles. Now yeah, I can't think of any other way of doing that. So it's question 5. The way you solve a quadratic inequality is with a graph. So the quadratic inequality is that. We're first going to graph this. Best way to graph a quadratic, since we know it's got a basic bucket up or bucket down shape. In fact, this one has a bucket up shape because the coefficient of x squared is positive. It's just to find out where it hits the x-axis and the y-axis. The y-intercept is pretty easy, it's 35. The x-intercept comes from making y 0. Hopefully this will factorise so I don't have to complete the square or use the quadratic formula. And it does, yeah, there we go. -5 times -5 is certainly positive 35. negative 5x combined with negative 7x is only negative 12. So therefore x equals 5 or x equals 7. So our parabola goes through the x-axis there. We already know it's bucket up, so that's the answer. And what this is asking is, when is your graph lower than or equal to 0? So it's there. Converting that into the terms of the x-axis, scanning the x-axis, is the graph for this value of x down low? No, it's not, it's up high. So that's no, 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 no. No, 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 no. It's not just down below, it could be on the x-axis, so that one's fine. These are all fine, they're genuinely below, that one's fine too, and these aren't. Now finally, to answer the question by expressing that algebraically, we just ticked all the values of x that are between 5 and 7. Maths has a expression for the word between, there it is, and that's the answer.